Just monitoring the chat window as well. But okay, yep, I'm hearing some feedback, so let's go ahead and get started officially. So thank you for tuning in today, everyone. I'm going to be going over joining and cleaning datasets using Python and Pandas. And I'm going to talk about the importance of why you join and clean datasets as part of the start to the machine learning process. Here is the agenda that I'm going to be covering for the next hour, starting with a quick welcome, then getting into a machine learning overview, and going through some examples of joining and cleaning datasets, and then share some next steps and resources. And finally, I'll hope to leave some time, maybe 5 minutes at least at the end for Q&A. But I do want to encourage you all to ask any and every question that you have during the stream. Just feel free to get chatty in there. I see people are already tuning in and kind of saying where they're from. So feel free to just follow along and leave any comments or questions that you do have. Some of my teammates are also in the Twitch chat. So if I'm not looking at that at the moment, someone will be able to answer your questions there as well. So my name is Megan Lewis, and I am a senior program manager at Microsoft in the Cloud and AI org. And what I do is I primarily focus on the Microsoft Reactor worldwide locations, and I create content in the form of workshops, and I go and deliver content at our Microsoft Reactors. So I have an edge for emerging technologies in particular, which basically means I get to go and explore exciting and trending technologies that might be great to have content, so workshops or tech talks for at our reactors. And it's a lot of fun just getting time to play around with different technologies. I think at the heart, I am a technologist, so it's really cool to be able to have the space to go and explore different technologies and then also come and speak at the reactors, either in person or online, and just meet a bunch of like-minded technologists who are just curious and want to learn as well. I have left my contact information there, so if you want to get in touch either on Twitter or LinkedIn, feel free to reach out if you just have questions, or if you want to suggest some new content that we should be looking into and bringing to reactors, please let me know. So I want to talk about the reactors. I am going to just make the assumption that a majority of you are here today because you're part of our meetup community on reactors, and that you found out about that event from there. So if you want to learn more about the reactors, you can check us out at our website down there, developer.microsoft.com/reactor, and also engage with us on Twitter at MSFT Reactor. We're very active on Twitter, so that's a great place to reach out to us if you have any general questions about the reactor spaces. Generally, they're just spaces where we bring together a community of folks, technologists, developers, students who want to learn more. So like I mentioned, we put on a series of workshops at the reactor. So we cover topics like data science, AI, machine learning. We're constantly working to develop new content as well. While we have more traditionally focused on in-person experiences, we are currently putting those on hold in light of the coronavirus. So we are now starting to experiment and have really accelerated our plan for experimenting with online experiences as well. So now we're starting to do these live streams on Twitch. We're also experimenting with live Q&A on Twitter. So we had our first one was yesterday around Python. And so every week we're going to be doing a new Q&A around a specific technical topic. And we're also working on pre-recorded videos for our Reactor YouTube channel. So that's just another outlet to go and watch videos and kind of continue learning about different topics. So now I want to get into what is machine learning. So like I mentioned at the start, this is all about cleaning and joining datasets, but that is a very important first part of the machine learning process and cycle. So machine learning is a data science technique that allows computers to use existing data to forecast future behavior, outcomes, and trends. And it can also help to categorize items and detect anomalies. By using machine learning, computers learn without explicitly being programmed. Instead, they rely on learned patterns and infer decisions with minimal human interaction. So now I want to just talk through some of the 5 questions that you can answer with traditional machine learning. So the first is around this classification model. So there you're asking the question, which category does this belong to? And what you're trying to do is simply assign a category to each item or data point. So a good example here is you might provide a picture of a dog, and your classification model can identify what kind of dog breed that is based on the picture. Or you can have an item like a piece of trash, and you want to identify, is this actually trash, or is it recyclable or compostable? So you're able to classify some of these different items. Next is with regression, where you're asking the question how much or how many of something that there are. So what you're doing here is predicting a real value for new data given past trends in the data. So a common example for this would be looking at the sea level rise and looking at the trends over the past century, and then being able to predict going forward how much the sea level might rise in the next century. With anomaly detection, you're asking the question, is this weird? So anomaly detection is the process of identifying unexpected items or data which differs from the norm. So here you might be swiping your credit card. So every time you're using your credit card, you're adding a new transaction to the list of past transactions for your own credit card. So there you're able to look at trends and how you're spending and where you're spending. And this is a great way to be able to detect very early if there are unusual spending patterns and detect fraud. Next up is reinforcement learning. So there you're asking the question, what next? So this is about being able to take some appropriate action or next step to maximize the reward in a particular situation. So it's really about allowing a machine to figure out the next logical step and the path forward. So a good example here is thinking about a Roomba, a robotic vacuum cleaner, that is able to identify the room and kind of go back and forth and vacuum the whole room, and then be able to identify actually when it's done cleaning, like, hey, I vacuumed the whole room, and now I can go and return back to my docking station. And then there is clustering or recommenders. So here you're asking the question, are there clear groups that I can separate this data into? So typically with clustering and recommending, you start out with some unstructured data, and you don't necessarily have a great way to categorize or cluster this data in any specific group. So you kind of go through experiments to find the structure of data and organize it in a way that is acceptable for you. So an example of this might be a streaming service. So you're at home, you're watching movies, and after you've watched a certain amount of movies, your streaming service might then say, hey, I think based on what you've already watched, that you would like these movies. So it's able to recommend based on your past behavior. So now let me talk about machine learning modeling. So I'm going to start over with the left column of cleaning data. So most data typically needs to be cleaned before it is used. So examples of cleaning data include removing duplicate values, deciding what to do with missing values, like replacing them or dropping them. You can be fixing typos. So if the data had input that was entered by humans, sometimes there are mistakes. So you have to kind of clean up that data and get it in a standard format to be able to use. Then you would move on to filtering data. So in that step, you would kind of take and just choose the data from your data set that you want. So you might not need all of, the different columns and rows that are available in that data set. So this is a nice way to just filter out the specific information that you're looking for. And then once the data is ready, you can select an algorithm and start to build up your model. Then you would provide a training data set in order to train the model and iterate over the data and then start to find patterns in it. And after that, you would provide a testing data set where this is where you can really start to validate your model. And then comes scoring and evaluating the model. So there you're able to tell how well the model is able to answer the question you originally sought to answer. And machine learning is a trial and error process. So it is totally okay to go back and repeat any and all of these steps, kind of until you get the optimal results for your scenario and you are satisfied that the original question that you asked was answered. So why clean and join datasets at all? Why is this important? So as a general rule, data scientists assume that about 80% of time and effort is devoted to cleaning and preparing data for analysis. Because most real-world data is split among multiple existing datasets, this invariably means cleaning and joining different datasets together. Data cleaning can be a very time-consuming task, but mastering the skill is absolutely necessary for data science and machine learning. Again, this is the very first step of being able to prepare your data and then being able to use it in various machine learning models. So before you can even begin to build, test, and deploy your models, you have to make sure that you can actually draw accurate conclusions from that data and get it in the state that you need. So, now I'm just going to go over the tools that I'll be using for the demonstration. If you do not already have these tools, don't worry about it, but I do want to give a heads up that this is what I'm using. So I have Python as the programming language, VS Code as the editor. I'm also going to be using the Python extension for VS Code. And as part of that, I get Jupyter Notebooks. And so Jupyter is an open source project that allows you to easily combine markdown text and executable code together. So I'm going to be using Jupyter Notebooks, and because of that, I need the Jupyter package. And then I'm also going to be heavily using the Pandas library. And so the Pandas library is a very fast, powerful, and flexible library built on Python that allows me to do a lot of data manipulation. So doing things like cleaning and joining and kind of combining data sets. So if you're not familiar with some of these tools, it's totally okay. You can go to aka.ms/reactors_online, and there you'll find a couple different things. So first, you'll find some setup instructions. So in setup.md, there's a markdown file with links to download the tools that I described on the last slide. And there you'll also find the Python notebook file that I'm going to be using today, so joining_datasets.ipynb. And so now let me transition over to open up VS Code and start to walk through that notebook and get into some of the demos. Okay, just one moment. All right, so now that I have VS Code open, if you have navigated to that link that I just shared, you'll notice that this is going to be the contents of that online directory. So I'm just going to go ahead and open up the Joining Datasets notebook, and that will just take a moment. One sec, I think I was eager and double-clicked. So now I'm going to just go ahead and hide the Explorer, so that's a little bit more clean. All right, so now I'm ready to go. I'm going to just explain a couple things first about the notebooks in particular. I think that this will be helpful and it'll become very clear as I go through the notebook, but there are two different types of cells. So each of these sections here is what's called a cell. So there are markdown cells, which are indicated by these curly braces here. And then there's also executable code, which is indicated like this, and it has a little play button next to it, so you can run this cell. So that's kind of the important things to know about Jupyter Notebooks for now. You can easily see when I run a cell, actually, so I can either press the play button to run that cell, or I can use the shortcut Control-Enter. And what that will do is execute that cell, and then you'll notice it's executed because now these brackets have a number 1 in there. So I'm going to be going through and using a data set, and the data set I'm using is the one mentioned right here, the National Nutrient Database data set. So I'm going to be importing that and kind of going through some examples of joining and cleaning those data sets. So let's get into it now, starting just with a reminder about importing variables. So if you have used Python before, you might be very familiar with this import statement. So this is just how you import any libraries into Python, and then I say import pandas as PD. So that is the alias, or just a variable that I'm going to use to access the pandas library. And this is a very common convention used. So if you are using pandas, you should definitely just follow this convention like all data scientists do to kind of import pandas and just use that library. And next, I just want to look through a quick exercise. So in this exercise, I just want to highlight that you can kind of just start typing PD. Sometimes, VS Code and the notebooks will help you out to provide suggestions, just understanding what you're trying to do. So what I did there was just PD dot, and here I can kind of see a list of all the functions available of how I might use my pandas library. So a very common thing that we're going to be exploring are data frames. So data frames are two-dimensional array-like structures where they have rows and columns. So we're going to get into exploring a lot of data frames over the next 30 minutes or so. And additionally, I can put a dot after the data frame function to see what else is available and what I can apply to that data frame. So just a helpful tip to remember about working with any kind of functions, really, and notebooks, is you can just add that dot after to kind of see and get a list of ideas of what you can do with that function. So it's definitely worth just taking some time to play around with this, especially if you're not so familiar with pandas and data frames, to just play around with this a little bit and get familiar. So let's move on to the loading data section. So here, what I'm going to start doing, and this is basically the very first step that I want to take to import a data set. So I'm using, again, that National Nutrient Database set, which is here. And this is in that same directory where I have this joining data sets Python notebook. So here, what I'm going to do is to use pandas to call the read CSV function. And so I can run that cell. I just pressed Control Enter to run that cell. And what I'm doing is just loading this data set into a data frame here. So this is a variable called df, which now has my data frame, which is loaded from the CSV file. And then what I want to start to do is explore and clean the data. So a very common function to do that is just to say df.head. And this is a great way just to get a very quick peek into the data set that you're using. So here I see that my data it's showing the first 5 rows. And so that's what this head method actually does. It shows the first 5 rows by default. And then I see all of the columns, which are 53 columns. And then I can see a couple different things here. So on this very left-hand column, I see the index. And that will just increase sequentially for all of the rows in my data frame. And here I have this NDB number. So that's the nutrient data bank number. And this is the key for this data set. So this is unique for each and every item within that data set. And then I also have the short description here. So this will most likely also be unique to whatever the item number is. So you see that even between these first 2 rows, there's a very slight difference, butter with salt and butter whipped with salt, but that they have different keys and because they're different items. Then I also just see a lot of other nutritional information about these foods. So now let me explore the df.info method and what I get from that. So using df.info, I can see some really helpful information about my data frame. So here I see the class that the info method came from. I get the range index, which says I have 8,790 entries. And so these are my rows in the data frame. And those rows go from index 0 to 8789. And then I also see the number of columns that I have in this data frame. So all the columns are listed out on the left here. And then when I move across the row for seeing what this column is, there are 8,790 non-null items in this one column. So what that indicates basically is that there are no missing values. So this is super helpful to know because as you scroll down and see what's in each column, you'll notice that there are a lot of situations where this number does not add up to the total. So that just indicates that there's a lot of missing data. And that's important for me to know when I'm thinking about what I'm going to need to do to clean and join my data to correct some of these missing values and just decide what to do with them. And then in the right-hand side, I just see the type of this column. So I see that this NDB number, my key, is of type integer. So it's a 64-bit integer. So there's only numbers in there, kind of like we saw up here, is that it's just a 4 or a 5-digit integer. All right, so now let's move on to start to explore the duplicated method. So this might be a great thing to do as well when you're just starting to explore the data to understand what's in there. You also might want to know, is there duplicated data that I might need to get rid of? So when I call the df.duplicated method, what I see is the first 5 rows and the last 5 rows. And I see that this is all false. But I mean, I don't want to look through 8,790 rows to kind of understand where there might be some duplicates. So there is a quicker way that I could do this by taking the df.duplicated.sum. So I can just call that method after duplicated. And this very quickly tells me that I have 0 duplicated rows. So after thinking back about the type of data set that this is and understanding that each of these NDB number keys represents an individual food item, it's not really surprising that there are not duplicates in that data set because all of the rows are unique. So for demonstration purposes, let's go ahead and mess this data set up. And I just want to go ahead and duplicate my data set, my data frame. So what I'm going to do is say df.append, and what I pass into this append method is a whole nother data frame. So I'm just adding another data frame right on top of that. And then I'm saying ignore index is equal to true. So what this is doing is just saying kind of ignore the index that's part of this data frame and just add it right on to the end of that existing data frame. So if my last index was 8790, the first index of this new data frame will be 8791, and then can continue the sequencing of the numbers. Now what I want to do is to group by that NDB number column, and then to take the count of all of the NDB numbers. Oh, sorry, I actually didn't run this. So there we go. Let me go ahead and run that. So now when I do this count again, I see that I have duplicate entries for all of my IDs, or all of my MBD numbers, sorry. And that is fine because I have just, in fact, duplicated the data frame. And so now I just want to start understanding how I can clean some of this duplicate data up. So now that I've identified where the duplicates are, I can explore this drop duplicates method. And here I pass in the column name, and I'm indicating that I want to keep the last set of duplicates. So again, I have one data frame. I added another data frame on top of that. So what I'm going to do is keep the last set and take the first set away. So now let me execute this. And here is what I get when I run df.info. So here I see that I have the same number of entries that I originally started with when I imported this data frame. But now my indexes go from 8790 to 17,579. And here I see the other same data about my data frame. None of this has changed because I now only have one set of the data again. So here, let me go ahead and execute this df.head method. And you'll notice that, again, this pretty much looks the same except for when I look over on this left-hand side and I see the indexes. So instead of starting at 0, they start at 8790. So now I just want to pose this question to you all. Is this behavior of the drop duplicates method, not updating the index values of the data frame, surprising or unexpected for you? And if it is, just can you explain why it behaves as it does in this case? Why do we have indexes starting at 8790 and not 0? All right, so if this is unclear, let me just, okay, cool. I got an answer there. Keep is equal to last. So yeah, that is exactly true. So if I just run through or go back up to this example, basically what I did was to say drop duplicates and keep last. So that does just keep the last set of duplicates as they are, including the index that's included with those. So it's just going to go ahead and copy, or not copy, but just keep those and get rid of the first set of indexes that were from 0 to 8789. And now let's get into some examples of splitting the data frame. So it might seem a little bit weird to discuss splitting a data frame in this talk that's all about joining data frames, but basically I'm going to just demonstrate how to split different data frames. It's very likely that when you're working with actual data sets, you might want to have very different data sets that you might want to join together. Maybe one data set has a set of data and columns that might be interesting to your analysis. So you want to find ways to be able to join data, but first let's just talk about splitting for one moment. And you'll see what I do with the splitting of the data frame so that we end up with different data in each set. So what I'm going to do here is to define a new variable, df1. And for that df1 variable, I'm going to say df, so taking my original data frame, and then I'm saying .iloc. And so this is integer location-based indexing. And I'm specifying the rows here, and this first semicolon, and then separated with a comma, and then this indicates my columns. So when I execute this, that was run. So now I might just want to hop down to say df1.info. So when I do that, I see that I have 8,790 entries, but what has changed is this 35 columns here. So instead of having the original 53 columns, I've just taken the first 35 columns, but all the rows. So a quick question to pose to y'all again is, why did we use the syntax that we did to get this data frame 1 to capture the first 35 columns of df? And what does the first colon and the square brackets do? Does that all make sense? And let me just take this as an example. So I can experiment, just in case that's not clear, I can experiment with just creating this data frame 3, where I'm saying df.iloc, and then I'm just passing in this slice of 35. So then what I can do, let me just try to add a new column here. And if I say df3.info, so when I run that, I see this is what's printed out. So in df3.info, I have 35 entries with a total of 53 columns. So this is just to illustrate basically that looking at this slice, this is kind of the output that I get, but that wasn't necessarily clear input provided, right? I'm not specifying the rows and the columns. I'm just giving some random slice, and the data frame is interpreting what to do with that, which ends up giving me 35 rows and all columns in this situation. So it's just taking that 35, saying 0 to 35, giving me the first 35 rows. Cool. And I think I see some responses there. So great. Let me keep going with that. I think hopefully that all makes sense. And now let's create our data frame 2 variable. So what I do to create the second data frame is a little bit different than the first one. So what I do is kind of use the same iloc, so this integer location based method, to specify the rows and column. And here what I'm doing is taking the first 2,000 rows, And then over here, I'm doing some concatenation. So here I'm saying I want to take the the 0 index of this data frame. So that is going to be the NDB number, that key. And then what I'm going to do is to say plus I for I in range from 35 to 53. And so what that allows me to do is to get that other part of the column. So in my first data frame, I have up until the 35th column. And then in the second data frame, I'm going to have that index column and then up until the rest of the column. So up until 53. So let me go ahead and execute this. And then let's start to explore what is in this second data frame. So when I do df2.head, I see that I have this index over here, so starting from 8790, which is what we expect after we have dropped duplicates and kept that second half of the data. I have my NDB number, and then I have this data. So this is a little bit different. So I know that this is, in fact, the last 19 columns of my data set because it starts out different. So this is alpha caret. And if I remember from DF1, it starts with the short description after the NDB number. So I know that I have separate data there. And looking at df2.info, I can kind of just get a glimpse of all that is in df2. So I see that there are 2,000 entries or rows. I see that there are a total of 19 columns. So then I'm all set there. I have successfully split my data frames into a different number of rows and columns. And then, sorry, I'm taking a moment to look at some of the questions. So isn't column index 0 on the NDB number? Yes, column 0 is the index of the NDB number. So let me just go back and check out what I'm doing to define this second data frame one more time. So I'm taking the first 2,000 rows, and then I am taking 0. So 0 is that index, that NDB number. And then I'm taking all of the columns after that from 35 up until the 53rd position. I don't understand why we use the for loop to choose some columns. Yeah, that's a great question. This, basically what I'm doing, okay, we can try to do this a different way. And let me see. So I definitely need to just keep that index, right? So I want to specify that I need the 0 index. So a way, if I wanted to do this very similar to how I did the first data frame, actually, sorry, let me go back up here. And let's just see if I'm going to define a new variable. So let's just see what would happen if I wanted to kind of define this in the same convention as I did before. So perhaps I would take the first 2,000 rows, and then I can separate with a comma, and I can say from 35 to 53, or so just take the rest of the columns there. And then when I execute this, I can just say df4.head. So let's start there. And then what happens in this situation is I have my index, but I do not have that NDB number. And that's going to be helpful for later on. I just definitely want to keep note of what that NDB number is, especially as you can see that my indexes might change depending on how I'm moving the data around. So it's important to go ahead and keep that column. And there was not really a clear way to do that here. So for example, I can't just go ahead and clearly define the index that I want to keep here in a nice way. So the for loop really just allows me to kind of concatenate the data that I need here. So I'm saying get this first part of the list, so the index, and then I'm iterating over this range to just add in the rest of the columns. So can't we do 1 plus 35? Yeah, so let's try that out. And I'm going to go back up to this example. One plus 35, and it would actually be 0 plus 35. So let's try out what happens when we do that. And here I get a type error when I execute this, like, well, maybe, sorry, that's not the exact syntax that you were asking. So let me try this. And here I still get an invalid syntax. And basically this is just not a valid way to define. So I'm passing in this index and then this slice here, and Python just doesn't really know how to interpret that. So I hope that that answers your question. I meant 0 to 35, yeah. So this is just not a clean way to do that. So now let me keep going. Sorry for all the back and forth. Let me keep going with explaining what we should do after we've split these two data frames. So I have df1 and df2. Remember, df1 has all of the rows in the first 35 columns. df2 has 2,000 rows, the first 2,000 rows, and the latter half of the columns from 35 to 53. And we have explored that data for df2. So now here's the data for df1 again. So hopefully this just will refresh your memory. And now what I want to do is use this reset index method to go ahead and reset the indexes on df1. So remember that the indices go from 8790 up until like 17,000 or so. And that might not be the most helpful when logical counting starts at 0. So now I want to experiment with resetting the index. And so what I do here is call this reset index method, and then I'm going to call the head method again to see what's happened. And so something a little peculiar happened here, I would say. So I have this newly labeled index column, and then I also have a new set of indexes over here that are the ones that I want, but the old indexes are still there. So this didn't work exactly the way I intended it to. That's basically because Pandas doesn't want to delete data that we might need. So we have to instruct Pandas actually to remove the columns, remove the index columns that we want. So we have to specify that by saying drop is equal to true. So I'm going to experiment with doing that again. So now that I have this data set with this index column and this other index column, what I want to do is to say to drop the index, axis is equal to 1, indicates that that's the column. And then what I want to do is to call that head method again. And so now when I do that, I am seeing my data as I expect. So I have dropped that second index column, and now I'm just left with my indexes over here going from 0 to 8790. And then what I want to do is to do the same thing to df2. So I'm going to call that reset index method, and I'm going to call the drop is equal to true to just go ahead and drop that index and use my default indexing. So now I don't end up with that extraneous index column. And then what I want to do now that I've kind of explored these data sets and split them up into different ways is to go ahead and write them back to a CSV file. So here what I would do is just say df1.toCSV, and then I pass in the name of that CS file. I'm specifying here again index is equal to false, so I just want to basically just take the set as it is and not worry about having to add in, or not worry about extra indices being added in. And then as an exercise, I can export df2 to a CS file, which would essentially look very similar as df1, where I can just go ahead and say to a CSV, and then I might want to pass that data into a separate CSV file. Oh, and then I forgot to mention this. So comma separated just indicates to separate my values really nicely in a column so that they'll be formatted in a CSV, and then I can easily read them back to a CSV as well. And encoding UTF-8, that's generally just the type of encoding that you want to use with any file, just to make sure that it's going to be compatible. And now I want to talk about joining data frames. So let's get into this and start to look at some examples now that we have split data frames, how we might be able to perform different joins. So there are left, right, inner, and outer joins are merges. So let's start to experiment with some of those on data frames. So what I'm going to do first is to execute this df1.shape. So I'm calling this shape method to tell me the size of my data frame. So I see I have 8,790 rows and 35 columns. And df2.shape, as a reminder, I have 2,000 columns and 19 rows. So now let's get into some of these joining using the merge function. So what I have to do, and I'm going to first experiment the left join. So now let's look at how this will work. So I'm going to say a new variable here called leftDF is equal to pd.merge. And so I'm passing in the first data set, the first data frame, df1, the second data frame, df2. I'm saying how I want to merge or join these data frames. So I'm using a left join. And what a left join means is that it's taking all of the keys from the left data frame and kind of comparing that with the right data frame. And I'm joining those on the column NDB number. So let's just run this and look at what we get. And so what happens in this situation when I've merged based on the left data frame, and so the left data frame had 8,790 rows. So what it's just basically doing is taking that so what's happening is I'm merging on the left data, df1 to df2. So it's going to end up taking all of those rows because of. Well, let me just stop and ask the question. Is the shape of the resulting data frame what you were expecting, and why or why not? And I can go back up to look at the shape of these two data frames again. So basically, df2 has 2,000 of those same rows from df1. So it's just going to go ahead and take all of the rows and then add on the additional columns. Since all of that data is the same, all of the NDB numbers in df2 are the same, it's just going to tack those on to the end. And now let's start to explore what happens next. And also note that this was a great way to kind of get back to the original shape of my data frame when I imported it from that CSV. And now let's also look at what the differences between these data frames might be. So here I'm taking my original data frame and looking at the head. So I can't quite see everything, but this kind of gives me a snapshot of those first 5 rows and some columns. And when I do the left df.head, I see kind of some of the same data here, right? Where I have the first 5 rows and some of the columns as well. So nothing really looks surprising in that first set of data. So now let me look at the tail. So here I can see, as I look over towards the right, that there are some not a number values. So that, let me go ahead and then look at leftdf.tail again. So when I look at leftdf.tail, I'm seeing those last 5 rows and the 53 columns, and you'll notice that there are a lot more not a number values. And this is because the left data frame was larger than the right data frame. So we had those 8,790 rows and 35 columns, and then we tacked that on to add the additional 19 columns on the other hand. But since there were only 2,000 rows and not 8,790, we're left with a lot of not a number values that Python and Pandas don't necessarily have values to fill for. So now let's explore what happens with the right merge. And as I go through, we just did the left. As I go through right and inner and outer, I think that this will start to make more sense. So let's explore the right df. And I can say pd.merge, and I'm going to take in df1 as my first data frame, df2 as my second data frame, and say how is equal to right. And then I want to join on that NDB number, so my nutrient data bank number. Oops, let me just correct that. So then after, let me just go ahead and say write df.shape. So this is basically the opposite of the left join. So before I was taking my left-hand data set, df1, and joining that on the right-hand side. And now I'm starting from df2 and joining that on the left-hand side. So when I look at the shape, I am left with 2,000 rows and 53 columns. So this is a little bit different than what we saw before. So basically, because from the right-hand side, we had 2,000 rows, those were able to successfully match up with a number of columns from df1, and then we were able to tack on all the columns. And then we can start to explore this a little bit further. So let me just do a write df dot head, and then I can see some of the values that are there. Again, I start to see the same kind of values. I can also look at the tail, which might be interesting to get an idea of what's happening with the last 5 rows of my data set. And here I start to see again some of the same trends where there are not a number. And now I'm going to look through what happens with the inner join. So the inner join will take the union of these two data sets and merge those together. So I'm going to have inner df is equal to pd.merge, pass in that first data frame, that second data frame, and merge based on the union of these two data frames. So when I do inner df.shape, what I'm left with is essentially the same situation as I just saw with my right join. So here I have 2,000 rows and 53 columns. So essentially this was the same as the right join. And I can further see that if I kind of did the same thing by looking at the head and looking at the tail and kind of just looking through that data and getting a little bit more idea of what happened in this join. And then I kind of answered that question why there are only 2,000 rows after performing an inner join. So again, an inner join here was essentially the same thing as a right join. So it looked at what was the union between df1 and df2, and what it was able to do was say, okay, the union based on these 2,000 rows that I have, this is what we have in common. And yeah, I can just start to run these so you can see the result of running the head method on the inner data frame merge and the tail. And again, this looks pretty much the same as the output. I know I'm just looking at a subset, but this is basically the same output as I got from the right merge. And so the last one that we didn't look at here was the outer join. So let me do an example of the outer join. But before I do that, I'm wondering, what do you think the result or the shape will be of the outer join? Feel free to answer that question while I am writing this out. Cool. And then I'm going to take outer df.shape. Typos. Okay, cool. So I see someone says 879053. So they're saying it's going to have the full set of rows, 8,790 and 53 columns. So let's see what we get here. And that is correct. So this is essentially the same thing as we did with the left join. So that is the resulting shape that we get there. And I just want to cover one more thing and just another example of kind of joining some data sets together. So now I want to be looking at 2 different data sets. So the first one is this first just nutrient database set that we were looking at. And I'm going to load that into my data frame. And let me just do df.head to see what's in that data frame, the data frame that we're very familiar with by now. And then what I want to do is to explore another data set. So for this one, I'm looking specifically at food groups. So I'm going to read in the second data set of just an additional set of nutritional values and nutritional guides. So then what I want to do is say use columns. So I'm specifying the columns that I want to use from that data set. So there I am specifying to take that key, the NDB number key, and then to look at the food group column. So when I execute this, I see the same key. And then I also see this food group tacked on here. So if I look at the shape of that food group data frame, I have 8,989 rows and 2 columns. And let me also look at the first data frame shape, which again, we're all very familiar with. So we have 8,790 rows and 53 columns. And then now let's look at this exercise. So we need to combine the first data frame and the food group data frame using the merge function. So let's think about the examples that I just went over using left, right, inner, outer, and think about what would be the kind of join that we want to do in order to put the food group column immediately after the NBD column. So any ideas on what kind of merge that I would need to use to make that happen? Let me start writing out a possible solution and kind of get some ideas on this. So let me just go ahead and combine. So my data frame and my food group data frame. I don't have a very good variable name for that, but we can go ahead and say a pd.merge. And here I want to take and my 2 data frames, so I can do df and I can do fg df, and then I want to specify how I want to do this join, and then I'm going to specify on how I'm on the column that I want to do this join. So I want to keep the NDB column, and then now I'm going to fill in the method that I'm going to use to join, which let's just go ahead and use a left join. So let's see what that gets us. And I'm going to need a new cell here. And so what I want to say is df_fg. Let me do a .info. We haven't seen that function in a while. And so was that what we might have expected in this situation? All right, so this was in fact not what I expected in this situation. Again, I want to have the food group column immediately after the NDB column. And basically what I'm left with here is the same amount of entries and now 54 columns actually, but I have the food group column all the way at the end. So that wasn't exactly what I wanted to do. So let me just try this one more time. So I want to put the food group column immediately after. So instead, I guess there's a couple different things that I can do. So let's try out what a right join would look like here. And then now let's do the same info. And here I have 8,989 entries, which remember I started out with this same number of entries or rows for the FG data frame. But again, I have that food group column all the way at the end. So now I'm just trying a few different examples, but that's not exactly the right shape that I want either. So let's try to do some switching of data here. Oops. So let me go ahead and try to first specify the food group data frame and then my second data frame and try a left join, and then to try to print out the info there. And so here I get my intended result to answer that question there about how to get the food group column immediately after the NDB number column. So sometimes you kind of have to do a trial and error to figure out the result that you're looking for. And that's okay. That's probably a good way to experiment using some of these different joins if this is confusing to you, to just try to set out with a question that you have in mind and answer that question. So now what I have is NDB number, and I do have the food group right after that NDB number column. So I do encourage y'all to go ahead and just try this out, especially any parts of this that you found a little bit tricky, but it's definitely a trial and error process, like I said in the beginning, of kind of being able to clean your data and get it into the state where you are happy with it so that you can move on to the rest of the data analysis process and begin to do some really interesting things like build models, train, test, and deploy models. So that is all of the content that I have for now. I do want to switch back over to the slides momentarily. And I just want to share a few resources that will be helpful. So first, I shared this at the beginning, but feel free to go and explore this on your own. So go to aka.ms/reactors_online. And from there, you can look at the Joining Datasets notebook and also kind of get a feel for other resources within that online directory. I also have the data files, and this is part of our greater Reactors repository where we store all of our workshop content. So you're welcome to go through that on your own as well. And then if you want to take it a step further after kind of getting a really good grasp on some of this material, you can explore lots of our great Microsoft Learn content. So Learn is our online platform. And there we have a lot of really detailed and nice tutorials of how you can actually start to apply what you've learned to kind of use some of these machine learning models and concepts. So I have these documents or resources listed here. I could also just paste them in the chat of how you can be able to get started with using machine learning and kind of build up your skills there. And then I also just want to end with a call out about free Azure for your next experiment. So you can go to azure.microsoft.com/free to get some free credit. So you can get $200 free credit for 30 days, or if you're a student, you can get $100 free credit for 12 months. And that is about it for now. I just left up our contact information again about how to get in touch with us at the Microsoft Reactor on Twitter, or how to get in touch with me. And then I think that I have 2 minutes left for questions. If there are any questions, let me check the chat stream now. Cool. And while I'm here, let me just go ahead and paste these resources in. Oops. I'll just paste them in right after the chat, but I think that's it. So I'll hang out just for a few minutes to answer any questions that I didn't get to. But I just want to thank you all again for tuning in today. Our next live stream will be next Tuesday, and we'll be exploring some web development concepts next week, starting with CSS selectors. So thanks again, and I hope that y'all have a great day.